Hey, I just wanted to check in before we start and say that I'm recycling this video from another class, so the output looks a little bit different. That's just because the defaults in R for how to define variables are different than they are in JUMP, and that can change the coefficients, as you know. So I don't think it's going to cause any confusion, but if it does, just let me know. So in the previous section, we assumed that there was no interaction between location and size, and that's because we were using an additive model. So an additive model has two separate terms. You have the term for x1, which in our case is size, and the term for x2, which is location, and those are two separate terms. So in this additive model, there is no interaction term, and that means that you're going to end up with parallel lines. So if you were you would have parallel lines for your regression equations. But we haven't actually checked that assumption yet. So let's look at this graph here where we allowed the two slopes to be different. We didn't force it to be perfectly parallel lines. And you can see here in the sample that it's not perfectly parallel. So you've described interaction before in the context of categorical predictors. So I'm going to have you try to do it in this context where you have a quantitative predictor. So just to remind you what it means to have an interaction, interaction means that the effect of one variable changes based on the level of the other variable. Okay, so take a second, pause the video, and try to describe in context what this interaction looks like. Okay, so there's obviously lots of different ways to word this, but let's just look at two sort of basic types of descriptions. One of them would be in terms of the size effect. So we can see that both of these lines have a positive trend. So we could say regardless of location, as size increases, the price tends to increase. As size increases, price tends to increase. So far, I'm not saying anything about interaction because I'm just talking about that positive trend. I'm not actually comparing how the relationship changes. Okay, so I need to add a but here. But for houses on the lakefront, so we can see for houses on the lakefront, we have a little bit steeper line. So how can we describe that in context? We could say for houses on the lakefront, the change in price for each square foot added is larger. And we should say on average because this is a slope interpretation. Okay, so that's a way that we could describe the interaction in terms of the size effect, right? Basically discussing in context how the slope of those two lines are different. The other way is that we could talk about the location effect. So again, we may want to start by pointing out that there is no cross in these lines, right? The lakefront homes always cost more than non-lakefront homes on average. So lakefront homes always cost more than non-lakefront homes on average. So we can see this because the lake houses, the red line, is higher than the blue line at all points. But we want to talk about how it changes. That's where the interaction comes in. But the difference is bigger for larger homes. So in other words, the effect of being on the lakefront makes a bigger difference for larger homes than it does for smaller homes. When you get to the Socratic questions, there'll be another opportunity to describe an interaction, and I'll make sure to give feedback on those because sometimes it takes a little bit of practice. Okay, so this is describing the interaction in the sample, but maybe this happened by chance, right? These aren't too far off from parallel, so we want to see, is it possible that they really are parallel lines in the population? So before we can test for an interaction, we have to have a model that actually includes an interaction. So notice this new term that the additive model didn't have. This is the interaction term. So it's literally just taking x1 and x2 and multiplying them together. So R will do it all for you behind the scenes, but you could imagine creating a new column in your data table that's just the size multiplied by the indicator for location. Okay, so when we set up our test, it's going to look pretty similar to what we've done before, but we're going to be testing beta 3. So this is the term that goes with the interaction. And the null hypothesis would be that that term is equal to 0. So basically, if that slope is equal to 0, the whole term drops out and you're back to the additive model, right? That would be no interaction. Whereas the alternative would be that there is some kind of interaction. Usually that's going to be a two-sided test. So beta 0 is not equal to 0 means that there is an interaction. But we're going to test this just like we would any other slope. We're going to use this t-statistic and p-value that go with our new interaction term. So because our p-value is small, so we have a small p-value here, that's going to give us strong evidence of an interaction. And we do want to go ahead and talk about this in context. So strong evidence of an interaction between size and location. And just to be clear what we're testing here, this is an interaction between size and location in the population. Right, we already knew that there was an interaction in the sample, but this is saying we've got strong evidence that this is real, that it's not just a fluke in that sample. And one more warning I wanted to give about interaction is that interaction is not the same thing as association. A lot of times just in regular conversational English, we use them interchangeably, but they don't mean the same thing here. So an interaction, which is what we were doing before, that involves 3 variables actually, right? Because, for example, we would be looking at the relationship between size and price and how that changes based on location, right? So that involves 3 variables. Whereas association is just about the relationship between 2 variables. So let's say that we were interested in the association between size and price. Let's say we were interested in the association between size and location. So you can see in this plot, I don't have anything about price at all. It's just the relationship between size and location. And you can see here a trend we talked about earlier, that the lakefront houses do tend to be a little bit larger, right? So here we do have a slight association between location and size. And the way that we can see that there's an association between location and size is from this tendency, right? That lakefront homes tend to cost more.
Oops, don't write that down. I misspoke. I meant to say that lakefront homes tend to be larger because right now we're talking about the association between location and size, not location and price. We'll talk more about the distinction between association and interaction later on.